All right, so what's up, guys? I'm going to go over, so this is Unit 2 for physics, and this is where we start to get into the study of motion, kinematics, both one-dimensional, free fall, two-dimensional, both moving vertically and horizontally is the two-dimensional. So this is going to be one of those things, this is where you'll start to see um, more equations coming in. We need to make sure that we're drawing things out so we understand what way they're moving and things of that nature. So let's start kinematics and the study of motion in Unit 2. All right. So the big ideas of kinematics, there's four of them, right? So the first one is um, the difference between displacement and distance. Distance will always be positive, no matter which way is traveled in terms of the starting point. So keep that in mind. So distance, if we drove from here to Philadelphia and back, our distance would be the total distance that we traveled, both up and back. We're not subtracting it. It's not displacement. It's distance. So distance is always going to be that positive number. When we talk about frame of reference, we talk about why that's important because you have to be able to describe the motion based on what your point of view is. Okay. So frame of reference, how we're looking at something. So if we are sitting on the beach watching a boat go by, we can see that the boat's moving. Okay. But if we're on that boat looking at the beach, what does it look like is moving? It looks like the person on the beach is moving away from us, right? But really, we know that it's the boat that's moving, but it's that point of view that if we were to describe the motion that we see, we would be saying the person on the beach is further and further away from us. Okay. So that's the frame of reference and why that's important. And that will come into play, especially for frame of reference and starting points for when we talk about displacement and distance. Then we talk about scalars and vectors. Okay. Scalars are when a measurement is scalar in nature, it only has one component to it, and that is the magnitude, which is the number. Vector is the magnitude and a direction. So scalar would be speed, vector would be velocity. Speed is just like if you look at a speedometer, it doesn't tell you what way you're going, it just tells you how fast you're going. A vector is the magnitude, whatever your speed is, but it's also going to be the direction that you're traveling. So that's the difference between scalar and vector. Scalar is the magnitude or the number. Vector is both the magnitude and whatever direction that you're going in. And then finally, fourth, velocity, speed, and how to compute. Okay, so we're going to start with equations here. It's easy. It's the triangle that you guys probably have done in middle school, actually, to be honest. But we'll be able to do velocity and speed and distance. It's the easy equations that we're going to do with this. Okay. So the differences between distance and displacement. So differences between first, before we even get into that, let's talk about a little bit of background information, some definitions, and so kinematics is the study of motion. It's the study of movement. Everything is in motion. But we know an object is in motion. We can look at it, and that's when we talk about frame of reference and point of view, but you may not be able to tell that it's in motion. Okay. Everything always has a starting point, and that starting point is called a frame of reference. You're starting at that spot. Okay. Position is the definition of a location of an object at a very specific time. Now, depending on where it is from the starting point or the frame of reference point, it could be positive, it could be negative, okay, in terms of displacement. In terms of distance, it will always be positive. Distance traveled will always be positive no matter what direction you go in, okay? because of the frame of reference that we know something, that are how we're going to describe something, we're looking at and from where. All right, so displacement versus distance. Here we go. For displacement, it's always about the starting point. Okay? Whatever that frame of reference point or starting spot is, right and forward from that spot is always positive in relationship to the starting point. Left and backwards is always negative in relation to the starting point. So, if I start here, sitting at my desk, in my chair, okay, distance will always be positive. You cannot ever travel a negative distance. So, if I'm sitting here at my desk, this is my starting point where I'm at right now, okay? If I push off my desk and go backwards, that wasn't smooth, but you get it. I've traveled a distance that is a positive number, but because I've gone backwards in terms of displacement from my starting point, I am in a negative displacement, okay? I'm in a negative displacement, but my distance traveled is positive. Right now, if I come back to the starting spot, which is right here, my displacement is 0, okay? Because I've gone back to where I started from, and they were both straight lines. So my distance is from when I pushed off to where I ended, and then where I ended back to where I am now. That would be the distance traveled. But my displacement is 0 because at my starting spot, I have covered, I'm right back where I started. Whereas in terms of distance, that doesn't matter. It's everything that you've traveled is distance. Okay. So that was the demo. Hopefully, like, it was a little more. All right. So distance versus displacement. Looking at the picture. So somebody driving from their house to school. Okay. So distance is the actual length of the path of an object in relationship to its starting. So where it starts is the origin, right here, D-O, and where it ends is the final resting place of the object. So that would be out here in front of the school building. So the example measures both the distance and the displacement, and both of them would have a positive magnitude. Both of those numbers would be positive in nature. But what's going to happen when you return from school back to your home? But we'll get back to that later. Distance, in this case, so you're going from your house to a friend's house. Your distance would be the entire space. So the wavy road that you followed would be the distance that you traveled. The measurement would only be a number, and that would be scalar in nature. Your displacement, and that's your red line, would be the distance that you travel. Your displacement would be the small straight line from D to D, okay? From DO to DF, okay? So that is a straight line from where you started to where you ended. It's not the entire distance that you traveled. And that is a displacement is a vector measurement, which means it will have a magnitude or number and also a direction, okay? Distance, just the magnitude. Displacement would have both a magnitude and a direction. So if we go back to, hold on. Let's go back a slide. If we go back to this slide, okay? So we drive from home to school. You start the distance and the displacement at that point from when you've driven to your home, from your home to your school, is still going to be the same numerical measurement. Now, the displacement say whatever, forward or whatever you want, however you want to frame it. You could say forward, you could say east, you could say whatever, as long as there is a quote unquote directional that describes the direction that you went. What if this car leaves school and now comes all the way back home? What is its magnitude of displacement going to be? It's going to be 0. What is the distance going to be? The distance is going to be double whatever the initial drive from the house to the school was, especially if it's a straight line. So if it's that straight line where it goes to the school and then back home, the displacement would be 0, but your distance would be, say it's 60 miles. If it's 60 miles to school and it's 60 miles back home, it would be 120 total. And so distance will always be positive, and it will always have a positive magnitude. Whereas if a car doesn't have displacement, if it doesn't go back to the starting point, it will either be, depending on where it is, if it's forward of the starting spot, it will be a number with a direction. If it's on the starting spot, it will be 0. And if it's past the starting spot in a negative direction, it would be a negative number with a direction. All right. So that's distance and displacement. So let's talk about frame of reference. Frame of reference is if you are sitting in a train, okay? I don't know if this is going to work. Let's see. Oh, it does. We're sitting in a train. What's our frame of reference right now? Okay, we're looking out. Are we moving, or are those other things moving? You look at it. We'll run it again. You're looking at it. It looks like the railing's moving, the telephone poles, the wires, that train that's going by looks like it's moving away from us, right? That's what that looks like. So is the train the person is riding on? Is that train moving in terms of the frame of reference? No, everything else is. Okay, everything else appears to be moving. So what appears to be moving for the person located? Well, let's look at it again. The railings, the wires, this other train, they all appear to be moving as opposed to us moving, even though we are the ones that are definitely moving, because the last time I checked, trees, rails, posts aren't able to move. Now, I know there's a lot of AI out there, but I doubt it. All right. So continuing with the frame of reference, right? Another thing. This frame of reference looks to this person's reference. It looks like the train is moving as well. Okay. Okay. So it appears that the train and the surfers are all still, but still is moving. Okay. What if you were on the train? What does that do to change your frame of reference? If you were on the train, what would be moving? Everything would appear to be moving to you because you're sitting on the train that's actually moving. That's the frame of reference. All right. So scalar versus vectors. Scalar versus vector. Speed is scalar because it's just a number. Velocity is a vector because it's got both the magnitude and a direction. So speed is the rate at which an object changes its location. It is only a number, which means it's a scalar in nature and only need a magnitude. Okay, there is no direction. So when I say it, it's got to happen per hour, kilometer per hour, things of that nature. But I talked about this before. Pedometer. What does it measure? It depends upon the time. And what does it measure? It measures your speed. And then how far you've traveled depends upon the time interval. Why is speed scalar? It's because it's just how the object changes its location. It does not have to be a direction. It's the rate at which an object changes its location. It is only a number. All right, so the equations. Average speed is distance traveled over time elapsed. Time is distance traveled over average speed. And distance traveled equals average speed times. No, that should not be average speed times time. That should be time. Don't pay attention. It should be time. All right. So velocity. So speed is scalar. Velocity is the rate at which an object changes, but it also includes the direction. Okay. And again, it's going to depend upon the time interval. Why is velocity a vector in measurement? Because it measures both the magnitude and a direction that the object is traveling. The equations for this: average velocity equals distance traveled over time times distance traveled over average velocity. And again, distance traveled equals average speed times time elapsed. So you can see that's there. One-dimensional movement. Okay, thank you. So the different steps of one-dimensional movement, we have position, which is the location of an object in relation to a reference point. Displacement, which is the change in position of an object. Distance, the total length traveled of the path traveled by the object. Velocity is the speed and direction in which an object moves. Acceleration is the change in velocity of an object per unit of time, and that can include the change in direction or the change in the magnitude or both. So acceleration is one of those that it could be accelerating. You know, you could still be traveling in the same direction, but you could start decelerating. And if you are, that's going to be a change in your acceleration. And then MRU is the straight line motion in which an object moves at a constant velocity. And then MRUA is the speed increases or decreasing uniformly over time. So that's one-dimensional movement. That's not the only thing you can do. All right, the equation. We already started to talk about this. We all know this math you all want and love. All right, so just here's the triangle. So whatever you need to solve for, cover with your hand. So if you are solving, and whatever's left is going to be the equation. So if you are solving for distance, it's going to be speed times time. If you are solving for speed, speed is distance over time. And then if you're solving for time, it's distance over speed. So if you just remember DST, you'll be able to remember that what you just cover up for, and you're going to be good to go when it comes to the equations. But again, I'll give you probably the equations or at least the triangle, and then you'll be able to go from there to be able to decide whatever you need to solve for. Okay. If you have any questions, shoot me an email. This is the first lecture of the unit. I'll probably give you guys some DST questions that you'll be able to do, but just keep that in mind that there's multiple things. Scalar in nature is just a number. A vector is the number and directional. That's the big piece of what you need to remember. And remember, speed is just the number. Velocity is the number and the direction. All right, that's it. Peace.